We're solving for this integral problem here. So we're doing the integration by substitution, okay? So the problem is integral of t divided by t to second power plus 1 dt. In previous problems, we saw that we have the problem as a product, but in this case here, this one is, as a division, okay? So what's happening here is this one is integral of u prime of x divided by u of x dx. So we got to look at that format. So now it's the division, okay? So it's no more the product, but now it's the division that we have to look out for. So when we see this problem, when we look at the denominator here, we see that this one, when you take the differentiation of t squared, it is equal to what? It is equal to t squared plus 1. It is equal to what? 2t. All right? But there's something missing because this one is t on the top and it's not 2t. So we got to make an adjustment to begin with, okay? So to make that adjustment, this one means that you have to multiply this whole original problem by 1 over 2, and then you have to set that one to 2t over t squared plus 1. And again, the reason why we're doing that is because when you find the derivative of t squared plus 1, it gives you what? 2t. But because the original problem is t on the top only at the numerator, you have to set up a half so that you can simplify the 2 and the 2 and you are back to the original problem so that you never change the original problem. You don't want to do that, okay? So let's keep going. So once we get this one here, we're going to set up the denominator as u, like we did before in previous videos, okay? So this one is u equals to what? That is t to second power plus 1, okay? So that's t squared plus 1. So if that's what we have, so now we keep going. We got to then find du with respect to dt, as t is the variable that we're dealing with here, right? So that one is equal to what? T squared plus 1 is going to give us what as a derivative? 2t. We said that earlier. Now we got to, get out of it dt. So dt then is going to be du over 2t. Once we get this now, we go back to the original problem and then, replace. So that's what we call substitution. So we get back here. So that means we're going to come here. And then we have the half. So this is equal to, then we have the half, the integral now. Okay. And then what's happening? So we have our 2t on top over, then t squared plus 1 is equal to what? Is u. And then dt equals to what? It's du over 2t. Are you with me on that? All right. So then once we have that, what's going to happen? The next thing to do is to simplify. If you guys remember, if you went back to our previous videos, what did we do? Whenever we get to this step here, what happens is that we always got to simplify something. And that will make our lives a lot easier. Remember that all the time. That's what we're trying to do on this channel, making our lives a lot easier. So once we get that, what's happening? So this one is equal to, we can come here. So this is equal to, then we have half, and then the integral. Then that is equal to what? That is equal to 1 over u du, okay? Or some people can just put what? Du over u, which is just the same thing. Now, we got to find the integral of 1 over u. Now, the integral of 1 over u is just one that is glaring, that we should already know through our formulas. Because anytime you have to find the integral of 1 over a variable or a function, a whole function, so what's going to happen? So we're going to have 1 over 2, okay, times then is going to be ln of absolute value of u plus c. Plus c, because remember, we do not have a range or interval, so this one is an indefinite integral that we're dealing with, okay? So this is what we have. So that means anytime you find the integral of 1 over a variable or a function is equal to ln of that variable and the function. And also keep in mind that the power here is 1. That's the reason why we're doing it, okay? So we keep going. So this one is just the same thing as, having 1 over 2. So what is u? We set u before, that is t squared plus 1. So we got to replace it. We got to substitute back, okay? Reasons why we have this whole thing called integration by substitution. Okay, the process called integration by substitution. So let's go back. So we have ln then of what? T squared plus 1, absolute value plus c. Or we can just rewrite the problem as the answer as ln of, then instead of absolute value, we have parentheses here. So that'll give us t squared plus 1 here. That's just the same. Does not change the answer. So this is it, ladies and gentlemen. So keep in mind, so anytime that we're dealing with integrals, we sometimes got to think about, is it integration by substitution? Because remember, on many exams, you are not going to get this one. At this point, what we're trying to do, it's a separate thing so we understand what to use when. But afterwards, once problems are given, most of the time you are not going to get the instruction to tell you, find, solve this problem by integration by substitution. No, here we learn it. And then on the test, it's a different ball game. So that means it's not going to be said. You're going to have to detect it to be able to do it. Okay?